much about this question and came back to study it in the early 90s. And what I found was, I was a practicing architect in Chicago, and what I found was, over time, we know how to do good buildings. I mean, we have lots of programs and ideas, and we understand how buildings work, and we're getting really much better at the physical infrastructure side of good buildings. But good buildings in bad places are still bad ideas and harmful in lots of different ways. And we have to approach the problem from both the supply and the demand side of the question. The supply side being, the way we produce buildings, and the demand side maybe is how we design our cities, how do we move in between buildings, and how do we get to those other questions. So I'm focusing on typically how to operationalize this question. I think a lot of people and a lot of communities do visioning processes like we've done here in Champaign, and understand that they want clean and sustainable communities, but they don't know how to do it. It's really much more difficult, and I tend to focus on the how to do it side of this question. So that's what I'll try to relay to you today. And I'll talk about sustainability and planning and some of the tools that I'm involved with developing, and approaches that we've developed, and some of the outcomes that we've analyzed, and some of the lessons that we've learned. Now we have a quorum. The BRC folks show now we can get going. Sorry, I didn't know you guys were coming. I would have waited for you. I should have. I didn't know you were coming. So some of the things, from my perspective, sustainability is important. And the issues, we all, I think, know and understand the issues. There's lots of them. And they're complex, the connections between issues that we don't understand very well. But really, part of the question is what's happening. We've started to develop this understanding about footprint analysis, and maybe perhaps we don't necessarily understand the constraining systems and the way that we're maneuvering around these systems and global carrying capacity. And so the question becomes resource efficiency in some cases and resource conservation in others. And I'm going to run through a series of slides. I'll focus on depletion in some respects, and get myself back into planning by utilizing some stuff that Don Fournier here actually introduced me to in the 90s. And we focus on the energy question. The demand side of the energy question is all about fossil fuels and fossil-based energy systems, and the demand for these systems is increasing, and still increasing rapidly, and the renewable side is increasing at a much slower rate. But the supply side, as we know, is limited. Peak oil questions, where are we in this curve? So we have a demand that's increasing, and a supply that's decreasing, and a price that's going up and staying up, and now we sort of are getting that picture. These things are staying up. It's not coming back down. We're following these curves that King Hubbert developed in the 50s pretty carefully and well. We sort of understand what's happening. And in terms of where these energy flows go, the important part for me, and this is 1997, but they're all the same, there's about 100 quadrillion BTUs coming into the system, and there's about 30% of it, or a third of it, goes to residential and commercial buildings, industrial uses, which are things that happen inside of buildings, and transportation systems, and the way that we move around buildings. And to me, these are planning questions. They're not, arbitrary questions. They're planning questions. How do we do this in terms of a built environment? This is the crux of the matter. And when we look at electricity, it's even worse, because it's still buildings, residential, commercial buildings, and industrial processes that take place inside of buildings. But for every 3 we produce, we lose 2 of them. So it's even more important on the electrical side. But the focus here is the fact that these answers and the solutions that we're starting to develop, in my opinion, are planning-based questions. It's not just buildings. It's the way we maneuver around and through and transport ourselves to these buildings that become critical questions. So there's emission questions and water quality questions. These are all planning-related issues. And the little image is just the way St. Louis has expanded over the last 40 or 50 years, and they've doubled and tripled in size with a really small increase in population. And those kinds of statistics are really readily available, and we all know them. Chicago grows at like a 3 or 4% clip, but their land area increases at about a 35 or 40% clip. And so it's just this resource depletion in terms of available land. We're planning poorly. We're not developing in ways that are consistent with our visions, which tend to be about clean and sustainable communities. So we've got a real disconnect in what we're doing and what we think we should be doing. So the question might be, how can we facilitate better decisions? I mean, that might be the ultimate question. And we might say that we can facilitate better decisions by giving people an opportunity to see what the repercussions of those decisions are. That if they understand that a decision made today, has future implications, and here's what they might be, I think we can facilitate more sustainable land use and planning decisions. And this goes back to things that were happening in the 60s. I think in terms of discount rates and some of the work that Bruce Hannon did early on personal discounting and spatial discounting, and the way we don't necessarily look out very far as individuals, but as communities we do. We have 30-year planning horizons as communities, but individually we tend to look more closely 4, 5, 6, 7 years before we lose interest or focus. But communally we tend to focus on this longer range plan, and if we can help individuals to move towards that sort of communal discount rate, we'll be making progress. And part of that, I think, is helping to see the repercussions of these decisions. So questions when we're talking about engaging these issues, for me, revolve around these critical questions. Where are we? Where do we want to be? That's that visioning process that we go through pretty regularly as planners and as communities, where we decide we want a vision. But the questions, how do we get there, are a lot more difficult. It becomes a lot more intractable. And it requires that we have some way of measuring how we get there. It requires that we have some kind of tools. So our response to these issues has been the development of some of these tools and ways of envisioning and engaging the future. One of them that we've developed here on campus is this lean model that tries to look at the future implications of change and what the repercussions of those changes might be. So it's a decision support tool. It's a way of simulating land use change. Provides a basis for analysis because it gives hard quantitative data in some respects that you can manipulate and use for other things. It provides a lot of data. It provides a lot of spatial data, and I'll show you how it works. But it's a process-based environment where we try to engage people in these conversations, show them what's going on, how the model works, ask them to help us build it. Why is it wrong? Why is it showing things that won't happen in this community, for example, things that we don't typically know when we go into a place, and they'll help us by saying, everyone knows that won't happen here in Champaign. Everybody understands this process. Well, sometimes we don't understand those processes, and we need that kind of feedback from the local communities. So it's an innovative technology because it's a spatial and dynamic simulation model, but it requires this sort of embedded process, working closely with the community and understanding what their questions really are that really facilitate the conversation about improving decisions. Values to modeling. I mean, models, you can look at these. We all create personal models and individual models, and we all are part of this modeling process in some way or another. But I think some of the key things for us, complex systems behave in unexpected ways. Unintended consequences are really hard for us to get a handle on. The primary responses and secondary responses are really easy to understand, and tertiary responses and other responses are really difficult to understand, and sometimes complex models help us to get a handle on those kinds of emergent consequences. And models provide some kind of basis for understanding, because it requires that you think about a system in a very specific way, that you collect data in a very specific way, and that you look at it in a very specific way. And it really does help provide a baseline for understanding, and it helps the communities really, in our case, helps communities understand what's happening as a baseline condition, and so it improves the general conversation. If we all understand the issue that we're talking about, it actually helps. A lot of times we don't. We don't really understand what we're talking about in some respects, and we provide this baseline data and information. Next. So just a brief We have a laboratory here on campus, faculty, staff, students, to do this kind of stuff, to look at spatial and dynamic models and how to improve the decision-making process. The generation of this LEAM technology, it's a hybrid model, we call it, because it uses different approaches, cellular automata in some respects, but it's on a lumpy surface. It's not on a pure grid. It's on a grid, but we create a probabilistic surface for these things to move around on. So it's not a static landscape model, and it's not a CA model, but it's a combination of the two approaches. And it scales up and down really easily. We work at a really fine resolution, about 30 meters. Available data comes in at about 30 meters, which happens to be about a quarter acre, nice scale for suburban development tracts. But we're able to aggregate these things into really large data sets and work on really large geographies where millions and millions of cells are competing for space and developing probabilities. So we're able to scale it up and down. And we also developed it in a way that it can add or subtract things really easily, so that you can go into a new place, find a new idea of why things are happening this way, and incorporate it really simply and easily without going through a lot of complex programming. We have these modular structures that can change the way the model works fundamentally to adapt to the local condition. But really, the visual side of this is critical. And I'll show you how that works. But it really, the visualization tool becomes really important for a lot of reasons. So fundamentally, the framework, we divide the region into cells, 30 meter by 30 meter cells, and in each one of those cells is a model, and a dynamic model that says what's happening to me at every time step. And it's basically calculating a probability in each cell for whether or not it should develop and what it should develop into. And those calculations take place at, for us, yearly intervals, depending on the questions that come up or the conversations that can happen sooner. But typically, a year for development processes is plenty. But so every year, this cell says, what's going on around me? What's happening? How are the schools? Am I close to a transportation system? Are there any new things happening? Is anyone looking for housing, for example? What's the guy next to me doing? All of that stuff translates into a probability that cell might change into something. And then you roll the dice, and it changes or it doesn't change, depending on the outcome of the dice. If it changes, then the next time step, the guy next to it says, well, this guy changed into a commercial building. I'm much more likely to be a commercial land use next time than I am to be something else, or to change into something else, because he's got infrastructure and there's zoning questions that come into play and all kinds of other issues that make that much more likely to occur. And so once we get these new patterns in the lower right-hand corner, these emergent patterns start to develop over time, and then we start to say, well, what does it mean? So you ask the question, what if this happens, what if that happens, and you get new patterns, and then you say, so what? So what? I got a new pattern. Does it matter to me or not? And that's where, working with the community, you find out, well, what they're really concerned about is availability of water in Atlanta. Or what they're really worried about is school quality. Or what they're really worried about is water quality. We're finding, in some parts of China, that becomes a really critical question right now. And so you look at these new patterns and you say, well, here's how it affects schools. Here's how it affects water. Here's how it affects what's going on here. And those then become the important conversations. Do we care about that or not? I mean, it seems to be, sometimes it become really critical questions, and you might develop policies and you might develop some investment strategies to keep something from happening or encourage something to happen based on some of these outcomes. And that's fundamentally how it works. The way this translates, it's not a terrific picture, but this is McHenry County in 2030. Those yellow areas, the bright yellow areas, are new residential land uses, and the red areas are commercial land uses. And this is the snapshot of 2030. And so we develop these probabilities, and then we play that scenario out. And then we do a lot of work on calibrating the model both mathematically and using Delphi approaches, because the math doesn't work very well all the time, we're finding. It's a very difficult problem. The spatial statistics in themselves aren't necessarily a difficult problem, but calibrating with such few data points that we have from the past in terms of these fine resolutions becomes sort of difficult. So we work with the local planning groups and the local stakeholders and say, is this reasonable? Does this work or not? And if it doesn't work, why not? What are we missing? And so we do this iterative process of developing more localized models by improving what we have to fit what they're looking for. So once we have these, here's some analysis, really simple. We know that things happened in 2001 in the blue, and things that happened later in 2030 are in green. So we have this time structure. So you can see that if you had valuable or important lands that were being stressed, you could start to see when they start to get stressed, when they become critical, when they might get more expensive, for example, because development's moving out that way. And we're looking at the townships. You might start to see some townships are starting to slow down and some are speeding up in terms of their growth pressures. You can start to analyze these questions in different ways. You can also then throw these what-if questions at it by changing some of the parameters. So some of the parameters are accessibility to stuff, say employment, or accessibility to hospitals or cultural centers, or just trying to think of some of the things that we've done. And it changes then the outcomes. And this is one that we added a new interchange in the lower right-hand corner of this map off of I-90. McHenry County claims to be the only county in Illinois without a major interchange. They're lucky in lots of respects, but they think it's a problem. So we say, okay, what happens if you get one? At Route 23 and 90, and that red area becomes this new sort of commercial development that pops up just south of Marengo. And it becomes a question of whether or not this is a good idea. And so here's what happened. We aggregate these things into sections, for example, and we look at the comparison between the first go around, the baseline or the reference scenario, and the second where we added the interchange, and we see things move from red to blue. So they previously were in red areas, and now they've moved to these blue areas, and it becomes more concentrated in the Southwest. And is that a critical question or not? And so these are questions that really the community has to answer, that we're helping them by providing some objective information. Says this might happen. If you put the interchange in, this might happen. Now, what do you think of that? Types of scenarios we've looked at. Infrastructure becomes easy for us to do right now. Policy questions, and we're looking at encroachment questions on military bases. Economic development. We build the fundamental driver for this is an economic model that says here's how many jobs are coming into the region. That those jobs translate into households, which is an interesting process in itself, because we find that the connection between household creation and population is disconnected right now, that we spontaneously generate households by a reduction in household size over time. Places like St. Louis, you get 100,000 new people in a 10-year period, they get 400,000 new households. How does that happen? It's because the household sizes are decreasing. Vacancy rates in some parts of the city are increasing. There's lots of things that conspire to increase these, but it's not so easy. In some parts of Illinois, we're looking at in Effingham, for example, the population is decreasing and the number of jobs being created is increasing. How does that work? It's a shift in the economy. It's a shift from this manufacturing, agricultural based to service-based economies. More people have multiple jobs. More people are staying in the region. Maybe older people are staying in the job market. Lots of things are happening, but it's an interesting dilemma. Can that go on forever? I say, we'll do a trends analysis and find that there's no people in Effingham and there's 100,000 jobs. It's a logical outcome. So some of the implications then when we look at these, so how do we compare these scenarios, and how do we find out if we care about that question or not, is what we do. And part of it is the stress analysis, and I sort of alluded to it before, where because we have these probabilities of change, these mathematical probabilities, you can assess how things are being stressed. Any geography can be looked at and say, this geography is being stressed in this way, and here's how the stresses change when we do something else. In this case, there's aquifer recharge areas in McHenry County, given those two scenarios, that shifts from one part of the county to another. And so then it becomes an important question. Does it matter? What we also found was down in that aquifer area was some really high-quality farmland that was very productive, some of the most productive stuff that they have. And it becomes, it changes from agricultural land uses to residential. Is this an important question? The stress on ag lands in that area increases dramatically. And they want to preserve their agricultural heritage in the western part of the county, so now it becomes an important question. There's economic development questions and there's agricultural preservation questions. There's also hydric soils that change in terms of stress. And so now it's a much more difficult question. I mean, it's not so easy anymore that is this interchange a good idea or not becomes a little bit more difficult, but making decisions with good information, I think, or better information than they had before. Whether it's good or not is up for grabs. I think it's good information. You might disagree. And we can do this because it's this probability surface that covers the entire study area. We can do it for all kinds of stuff. Here's St. Louis. These are watersheds and how they're being stressed given one scenario and another. These are transportation build-outs for their long-range transportation plan. How does it change over time? How does it stress different watersheds? Some of these watersheds are critical areas that they're very concerned about, and some of the stresses start to shift to those places. They might think twice about some of these long-range plans. And we've looked at lots of things. We're connecting to transportation models in Chicago. We've connected to the St. Louis transportation model, where the inputs from the inputs to our model use speeds on the network, and those network speeds are derived from their transportation models. So it changes the speeds on the network. Things get congested, people start to move somewhere else. It takes longer to get to work, your travel times increase, and they start to shift to some other place. And then we do it again, and we run those transportation models, and we get new speeds, and it changes then what happens on the network, and that network change affects the affects the land use patterns. And then we're connecting to water quality models, air quality models. I mean, these are habitat fragmentation stuff. These are dissertation topics that some of our students have done. But some of them are becoming sort of endemic to what we do. The water quality connection, we're using Althea, which is a cell-based model produced at Purdue, and connecting it directly to the model. So every time we produce a new pattern, we get some water quality output. So here's how things are changing. It's a crude, cell-based thing, but comparatively, it's better information than we had before. And in terms of getting the information out, like I said, we tend to be what I call embedded modelers. We physically work with these communities closely to find out what their needs are. It takes a lot of time. In terms of research, it's very difficult and time-consuming. You have a lot of people who get really interested. We have public forums where we introduce these ideas and get people involved in the conversation. So it really is it's a neat process, and I enjoy that interaction. In terms of academic sort of interest, it's difficult. Action research kinds of questions are always very difficult, but it's a very rewarding from that perspective. And in terms of democratization, we try to get it out into the web and let people see what's going on, and create little tools that they can look at. Say, in this case, I think those are recharge areas in McHenry County, and here's the model sitting on top of them, and they can visualize this information and download it and see for themselves. It starts to empower some of the watershed planning groups, for example, have access to information that they might not have had before. And we're working closely with some of them to develop these capabilities in the Chicago region. We're modeling the 9 counties around Chicago and working with the watershed planning groups up there to give them access to the stuff that we're producing. And like I said before, I mean, a model, because it's data intensive in some respects, we collect a lot of stuff, and we collect a lot of valuable information in a very specific way that can be seen in a certain way and looked at and used for other things. It's not just the one purpose. There's lots of purposes. And we're trying to give access. We're trying to give people access to that information. And we've been all over the place, as you can see. Some of the lessons we're learning from this process. Feedback is critical. Feedback is really important, and one of the reasons that this works is because we're giving feedback quickly. I mean, if you want to know the future of a region, if you want to know physically what's going to happen, don't ask a model. Ask the planner. Ask Atkins and Fox and those guys who own the property what their plans are, and you'll get a good idea of what's going to happen in this region. But you won't be able to test any ideas, and you won't be able to do any alternative futures. You'll have one probable future. This enables you to do multiple things and get feedback and deal with multiple futures, which I think is critical. That there isn't one future. There's many possible futures, and we have to be able to deal with all of them in order to be more sustainable and get better solutions out. So the process can be more important than the model. That, I think I've sort of made that point over time here, but the process of modeling for communities can be sometimes really more important than the outcome, because they start to engage in conversations that they weren't having before. They start to look at data from a different way and a different angle, and sometimes what looked like conflict within the community becomes a non-starter. We were working in Traverse City, Michigan, where the question was a bridge construction, and the environmental groups were against it, and the planners, of course, were for it. It was going to relieve congestion. Everybody, once we start to look at this question and start to look at some of these outcomes, all of them agreed that congestion was an issue and that needed to be addressed. They just didn't want it addressed at that spot. And that became easier to handle because alternatives could be worked through. And you could see the implications of some of the alternatives and whether or not congestion was relieved or whether or not the wetland areas that they were concerned about were affected. The need to link multiple scales I'll talk about, but being able to scale up and down is really important because you do have to provide, even though we have a regional model, and I don't advocate getting too fine a resolution with this, but you do need to be able to drill down and look at things at different scales in order to answer some of these questions. So this action research really promotes emergent questions and in a really interesting way. Learn by doing is what we call it. Lots of costs and benefits. I've already talked about it, but lots of costs in terms of time. Benefits are in terms of helping communities make better decisions ultimately. So feedback matters. I mean, and some of these approaches that we're constructing are based on approaches that have been done by others. This guy, Steinitz at Harvard, has done this for a long time, creating alternative futures, but it takes him 2 years to produce an outcome. And, once we get set up, it takes us just a few weeks to produce that same outcome. Or maybe once we get going on the web, you can download it at any time you want. So it's the process of feedback and how quickly you get feedback that helped this dialogue move forward. And we've been advocating recently this comprehensive planning exercise where you use these models and these ideas to create a framework for comprehensive planning that happens all the time. It doesn't happen every 5 years or 6 years or 20 years. You're asking the critical questions in a region every year. You're saying, here's what we're concerned about today. We're concerned about ethanol plants today. What are the implications of the 5 ethanol plants that were planned in Effingham County last year? What are the implications of that? And then we study that question, and we give them some feedback. And then they can decide whether or not it's important. It turns out it's like a total of 20 jobs, and it's not the economic development boon that they thought it was, and it might actually be a problem in terms of water quantity, et cetera. So we try to give the feedback on the critical issues, and then the next year you have different questions. And those questions, those ethanol plants have already gone away in Effingham County. I mean, now they have new questions already. And so the next year you open it up and you do it again, but you have this tool and this way of doing it, this very systematic way of doing it that provides a basis for saving that information from the ethanol plants. If it comes again, we find out what we did and how we attacked that problem. The data is always available. It's a continuous planning question or process. Process matters. I've already hit this pretty much. The system memory, these things that models provide are important, especially when we're talking about remembering what happened. Visualization, I've already hit, is important for us. Really does reveal a lot, especially when you start to look at things. In this case, we were looking at Chicago, and we're finding Lake County is really an attractive place. Lake County is on the verge, and it has been for years, but it's really attractive from this pure geography perspective. And so the question isn't whether or not it's going to happen, because Lake County doesn't have they actually have a very slow growth stance. They're not necessarily interested in all of this stuff happening. The question might not be whether or not it happens. The question is how might they control it? How might they diffuse some of this pressure? What are the strategies that they might implement to keep some of these things from happening? Because it's a very attractive place to be right now. Underlying data can reveal behaviors. This is, again, going back to this process of collecting data, we sometimes find out things that we didn't know before. In this case, bridges can have a big impact on the way things work. This is one of our accessibility maps that say those green dots are employment centers, big employment centers, And every place then we do a gravity model and we look at how easy is it to get to these employment centers, and we're obviously using the network and we're using wide open speeds in this case. So when we first go down, we don't have transportation connections, for example, and we have to look at posted speeds, and we say, here's how this region works, which makes Illinois, this is St. Louis, makes Illinois look really, really attractive. Well, why is Illinois not so attractive? Why is it not growing at the clip that it should be, given these kinds of analysis? And then you congest the bridge, and you say, oh, congestion matters. That those bridges are perceived as really hard barriers, and they're slow. And once you're across them, it's going to be difficult to get back. You only have one or two routes. You don't have an unlimited grid like you do on the surface, and they become difficult to traverse. And so the congestion on the bridge mattered a great deal in this case. Provides a memory for, this is St. Louis again, I think we've seen it already. Scale matters, how levels interact, how these decisions, sometimes really small scale decisions have big implications in regions. And sometimes small communities making some of these small scale decisions can have big implications for the region, and they don't recognize it. One of the ways that we're starting to look at it was at Scott Air Force Base. Closing down Scott Air Force Base seems like a regional or a local question, but it turns out to be a really regional asset. It's like 15,000 federal workers, some money coming in from outside into this region that actually matters a great deal for people in Missouri, not just Illinois, but Missouri. And so the implications of them closing down, it wasn't a local question, it was a regional question. And things that happen at Scott Air Force Base become regional issues, even though they appear to be local. So we're looking at regional scales, and when we look at these places like Chicago and St. Louis, and we're in North Carolina, Don and I are right now, there's millions, there's 25 million cells that are interacting, and as computing power increases, it becomes less and less of a question. We used to work with NCSA because we needed supercomputers to run this stuff. And now we can put a couple of machines together and do it ourselves, and now we can get feedback in minutes, instead of hours. So the regional parts of these questions become, these are very complex questions. Urban land use questions are really complex. Anything that involves the social side of humans is complex, and these are very social questions. So they're very complex and intractable in some respects, and so you have to be able to scale these things and deal with them in multiple ways. So being able to scale up into supercomputing sort of exercises is important. But ultimately, it's about making decisions at the local level in counties and how they work. And this is a small plan. This is the comprehensive plan for Edwardsville, Glen Carbon, down in St. Louis, and this shows, we overlaid onto their zoning plan and show where the conflicts are. So part of it could be that the model's not capturing things. Part of it could be that there's residential pressures that they're not recognizing, or commercial pressures in places that they don't recognize. And so these are the conflicts. But it's going to help them ultimately plan better once they start to go through the process of not only analyzing these land use patterns, but then what the patterns mean and how they affect the city. So just to wrap this up and open it up for questions, this is, in my view, sustainability in general is a planning question. It's a big question that has lots of things connected to it, but planning is right in the middle of it in lots of ways. And I think when we look around the country and you go through these visioning exercises, you can almost name exactly what's going to come out of the visioning exercise. The same stuff that came out of Champaign County's Big Small All. It's the exact same stuff everywhere. Everybody wants clean communities, better schools, environmental sustainability, walkable. You can just sort of count what they are. The question then becomes, if we all sort of know that we want to move in this direction, the question then becomes, how do we do it? And how do we get there from where we're at now? And that becomes really the important part of it. Maybe we kind of agree what we're doing, but we don't know what to do next. And so these tools that are out there right now are helping us to make sense of these questions and helping us to move forward in developing approaches and I suppose developing approaches to making better decisions ultimately. I really blew through that. But I'm open for questions. Yeah?
Two questions. One is, how do you evaluate these models? And have you actually predicted something and seen it come true, or is it something that you just that's one? Number two is, have you ever used this model for, say, somewhere like the city of Chicago, where they're trying to go get companies from locations and drop people, but every dollar that you spend on share tracking or voting, maybe it was spent in an inner city neighborhood, maybe the implications are, the payback is a lot more. Have you looked at comparing where should that dollar be spent to subsidize something, and in terms of the greater potential to do a greater social?
So, two difficult questions. And I'll answer the easiest one first, because the calibration process is pretty straightforward. If you look at the literature, other models of this kind are being developed at the University of Washington in Seattle and other places around the country. That calibration issue is really important, and it's difficult. And there's there's data available in 1993, and now we have a good 2000 data set, and every place we go we try to improve that 2000 data set and make it up to date 2005 or whatever we can get. So you only have a couple of data points, and you're trying to calibrate this complex system on 2 data points or 2.5. Very difficult process, and we run through this process of starting in 93 and ending in 2005 and seeing how good we do, and then we go through this iterative work of weighting some of the factors and some of the submodels that we have to reflect the local condition. Some places slope is really critical, some places it doesn't matter. Some places are, retail centers are critical, some places they don't. Effingham turned out hospital location mattered a lot. The population was aging quite a bit, and those decisions, hospital locations and accessibility was affecting decisions. But really, in the end, when we look at the models, we have this process of vetting these models with a group of people to make sense of them. Because when we spit them out, the math doesn't always make sense. We look at the information that we get and we say, that's crazy. It can't be. This is not right. And the math says it's right, and the calibration says it's right, but it's not right. And the other problem we have is that we're doing scenario-based planning. And so when you're say you have 2 data points, you're looking at a trend and you're saying, well, let's extrapolate into the future. It's not right. That's not the future, right? So there's all kinds of potential futures, and once you change any of those variables, you lose that calibration. You lose those qualities. So we do the math. We get as close as we can to what the reality says, and then we work with the locals to say, do you trust these outcomes? And by working with them, they tend to trust what we're doing is being reasonable, because they're involved in the creation of it and the development of it. And if they believe that these outcomes are reasonable, then they'll believe that the differences between outcomes then are valid. And that's all that matters in some respects, because we can't predict the future, so all we can do is kind of assess what might happen. And so if our internal validity within the model is good, then we'll get good comparisons, which is the important part. The other side of that, then, have we been able to kind of work through some of these funding questions or investment strategies? We have, in St. Louis, there was an effort called More for Your Money. It was a group of interested entities, agencies, stakeholders, business groups that were concerned about where they should be making public investments and where they would get the biggest bang for their buck. And it was interesting for us because it was a group of people like this, and the conversations were, in my view, completely arbitrary. That they would say things that had no basis in fact or no data to back it up. That improving schools would attract people. We don't know if that's true. And truthfully, we've been working on that question for 6 or 7 months, and so far we can't find any data that says that an investment in improving a school will change people's land use decisions, because there's so many other things that come bundled with that decision, jobs, for example, all kinds of other things that make that really difficult to pull out. But these kinds of conversations were happening, and we said, you need to slow down, and we can help you to work through these questions and to build models that will help you answer these questions, and it'll organize your thoughts instead of being so scattered about what may take. You can build you can build a model that says, if we do this, then this might take place. You can organize people's ideas and thoughts by helping them through the creation of these models, and so that's what we did. And then of course there's the political side of that question, which we give good information. Does it matter? In some cases it doesn't. It's a political process, and the political processes don't always turn out the way that they should, or the way that data would suggest they should. And in this case, that's exactly what happened, because we built these models and we started to help them work through these questions, and then they disbanded and just said they couldn't get along politically, and it was sort of intractable, and they couldn't deal with it. But in a lot of cases, we'll build, we'll help people by giving them good data and information about potential outcomes like this interchange. All of the negative things that might occur because of this interchange, I'm not sure will overcome the political sort of pressure that they have from their constituents to move that forward. So it's still a political process that we're working within. Sorry, we'll go around the room.
Has anyone done a temporal study of how this area got the North Prospect, North Neal development, and how it ended up being as interesting an area as it is, and be able to take that information to other communities and say, look what you could have too if you followed this process?
Well, you know how that took place, and I mean, that's a political, that for sure is a political decision. What sort of really bothers me about that decision was that we, as a community, invested in that decision heavily. When I was in Chicago, communities would never make the kinds of investments that Champaign made on North Prospect. They would ask the developer to make those investments. All of the stoplights and the road improvements that the community put in place to make that happen, we all participated in. So anyway, that's a political issue. But yeah, we use those kinds of stories to point out the potential implications of some of these decisions that look like a good idea, but in reality are just moving around retail dollars, for example.
What I mean is, has someone looked at how that happened, what decisions were made that led to it, and why you don't even have numbers on the building so you know where you are in the development? You're trying to find a place. There aren't street numbers.
Yeah, no, I've not seen it.
You partially answered. I'll ask a question and then give you the background for why I'm asking. The question is, does this sort of planning succeed only when you find in place, when you arrive, a high quality of civic leadership and a community's desire for appreciation of good planning? The reason I asked that, 2 weeks ago I had the privilege of spending several days in Cairo, Egypt. Probably the most chaotic development I've ever witnessed. Explosive development of the urban area. No provision for arterial streets, no provision for sanitary sewers. A city already in transportation gridlock, surrounding itself by enormous rapid development of poor quality masonry buildings. It's just a tragedy unfolding, not the most elementary.
Yeah. I don't know that you're right in some respects, that you have to have some communal will to do good stuff in the first place. A good example of that is Will County, where the state paid us to go help Will County do stuff, and they had a little turnover in the planning department where the lead planner, who's a very progressive thinker, went up to what is now CMAP in Chicago from Will County, and the ball just dropped. And they were no longer interested in anything, and we did all of this work, and they're really not doing anything with it. And compare that with a place like Effingham, which is a very small community, and we're working in 5 communities around Effingham. Marion County has 15,000 people in the whole county, and they're concerned about land use, and they're concerned about these questions. And it's really interesting to me. I mean, Will County, which is struggling against these sprawling land use, really overtaking them. and they have very little interest in what the kind of help we can provide them in a place like Effingham, which is, I mean, from that perspective, nothing is happening in Effingham compared to Will County. They're really concerned about it, and they're very active and engaged as a community. It's not just one entity; it's the whole community is involved down there. It's really interesting. So yeah, there has to be some political will to do something about it before it can happen, and that can be a question. You know, like I said, planning is a political process ultimately, and it can be good decisions, bad decisions can be made. You know, even in light of good data and information, still bad decisions happen. And there's not, I mean, what I always say is, and people would say that a lot to me is, you know, why bother? And I say, well, you know, if a bad decision is made and there's good information to say that it's a bad idea, then at least there's fodder for the opposition. I mean, to say, hey, this was a bad idea, why did we do that? So at least there might be some future repercussions that weren't there before.
Seems like most of what you're talking about is infrastructure and business and commercial and residential. And you mentioned that you have local stakeholders and that they're very influential. But I wonder if you see there are opportunities to put in buffers along streams, linear park systems along streams, recreate wetland complexes, you know, instead of ever more retention ponds.
Yeah,
in idiotic places.
Yeah, we do that. We do that as well. Yeah, we definitely do that, and we do analysis to show how these buffers can help. We're trying to do low impact development analysis where we're saying, look, if you created a policy doing these LID sort of strategies, how can that help you? You know, it doesn't change the job and it doesn't change the household numbers, but it changes fundamentally how your water works in this region. So we try to make those arguments as well. But the first objective is to go there and help them answer questions that they want to know. And a lot of those questions actually are on their minds. You know, they're concerned about their water quality or the recharge areas or how much water ethanol plants use, you know. So those issues actually surface up quite often. Alternative strategies for stormwater detention, you know, those kinds of things are sort of more design questions, but we can help them with saying, you know, what about a big policy in the region? How might that help unite things? Kane County developed a really progressive stormwater management strategy, and that actually became the basis for all kinds of planning questions for development in Kane County. They use that to sort of force the question of, you know, the developer has to prove that they're not implicating the stream water quality. They're not downgrading their streams, for example.
Do you see opportunities to include some ecological rehabilitation along the way? Does that get done very much, or do people value that, or is there a way to maybe bring some education along to where its values increase as you go through the process?
Yeah, I think that's part of it. We're trying to do things like put numbers on them. You know, unfortunately, you know, I don't know how you feel about it, but you know, some people need to see that there's this ecosystem value it has a monetary connection, and that when you change something, it changes this physical number. So we're trying to do some things like that because people everybody understands a dollar's worth, but we don't always understand the worth of something that we can't put a value on. And it's a problem for some people in that, you know, we shouldn't be trying to value these things. We should be protecting them for their just because they're there, not because they're worth anything in terms of dollars for stormwater management. But so we're trying to connect things like ecosystem values and some of the work that, you know, Bob Costanza, and they've built some tools that do these things. We're trying to connect to those things to say, here's how those values change.
Is the city of Champaign or Champaign County using similar models as this?
That's a good question. They are, as of like last week, we're starting to work with them. We did some preliminary work about 2 years ago. We told them we would do it for free. You know, we wanted to be involved in what's going on in the county, and it's been unbelievably difficult. I think I've talked to every single planner in town about this question. I mean, usually we go in and there's interest and somebody's making connections and pulling people together. I've personally given presentations like this to I think about every single planning organization in this community to get them interested in doing these things. It's really been difficult. There's not a central place here. The RPC is not quite the focus. The cities aren't quite the focus. The MTD's not quite the focus, but they're all involved. And so it's been a really, really, really long process. It's taken at least 5 years. Yeah. We could have been doing stuff a long time ago.
What about water issues? For instance, we talked about the Oxford up there. Is there any way to protect the resource, the recharge area of those things, so that
Yeah, just not developing on them and not see them transform into something else. But the water quantity, actually, Don has been working on water quantity questions and connecting to this model on how much water is being used and what strategies for the future might be to reduce water use. He's developed a nice model that we've connected to show how things change over time spatially and how that impacts water quantity in the region.
about waste management? Just the waste part of it.
Waste, we have not looked at waste management.
When you get to development like that, it dissipates so much.
That would be easy to connect to. If we had information or if there was interest in developing analysis that looked at the waste generation and how it would affect the county. I think it's important in some places. I know McHenry County has a real problem because their soil is glacial till mostly, and so it's really pervious, and they have a really hard time with landfills, and they tend to truck their stuff out into Kane County where there's some clay and some layers. So it's a real question. It would be an important question.
So many places where they put these landfills over aquifers, and I mean, there's probably plenty of clay there to protect it for years, but there's other places where maybe there's no aquifer.
Yeah. No, right. I think it would be a good question.
We're going to have to hold things off for a bit so people that have to leave can leave, and then you can take all the questions you want.